Welcome back students. Previous video class we learned various statement of second law of thermodynamics. Second law of thermodynamics introduce entropy term. Entropy means disorderness or randomness of molecule of system. Now we have to learn Gibbs free energy. Second law of thermodynamics have many application. One of the important application is to predict whether the reaction is spontaneous or not under a given set of conditions. What is called spontaneous reaction? Without any external driving force or external applied force, the reaction occurs under a given set of conditions is called spontaneous reaction. For example, rolling a ball down the hill but never up the hill spontaneously. Formation of sugar solution when we mix sugar with water, but the reverse reaction does not take place until we applied external force. Heat flow from hot region to cold region, but reverse reaction does not take place until we applied driving force. Expansion of ideal gas into an evacuated bulb is a spontaneous reaction. Reverse reaction, that is, gas molecules collected into one bulb, is not spontaneous. From this example, we know the reaction takes place in one direction, that is spontaneous reaction. The reaction does not take place in opposite direction spontaneously, that is non-spontaneous reaction. Naturally, maximum number of exothermic reactions are spontaneous reaction. What is called exothermic reaction? Particular amount of energy is released when reactant convert into product. Or you see fireflies in night time. During night time, fireflies emit light due to release of energy. It is also one of the example for exothermic reaction. Respiration also one of the exothermic process, because in respiration process glucose combined with oxygen it convert into carbon dioxide and water. Along carbon dioxide and water energy is released. So respiration also one of the example for exothermic reaction. Combustion of methane also example for exothermic reaction. Methane react with the oxygen to form carbon dioxide and water. Along with the product 890.4 kilojoule per mole amount of energy is released. When we mix acid with base to give salt and water, this reaction is called acid-base neutralization reaction. It is also example for exothermic reaction, because along with the product 57.32 kilojoule per mole amount of energy is released. Sometimes endothermic process also spontaneous reaction. What is called endothermic reaction? Endo means in, therm means heat. So endothermic means a chemical reaction that needs energy added to it for the reaction to take place. So energy is taken in when the reaction is occurs. Give example for endothermic reactions: cold packs, evaporation of water, melting of ice. These are some of the example for endothermic reactions. When ammonium nitrate dissolved in water, it dissociates into ammonium ion and nitrate ion. This reaction is proceed only when 25 kilojoule per mole amount of energy is supplied for that reaction. So this reaction is a category of endothermic reaction. So we cannot decide spontaneity from exothermicity. Hence, we cannot decide on basis of energy change in system the reaction is spontaneous or not. We know according to second law of thermodynamics, increase in entropy, the reaction is spontaneous reaction. But not all reactions, if increase in entropy, spontaneous reaction. So we need, in addition to entropy, other thermodynamic function also needed for explaining spontaneity of a reaction. So for that purpose, in 1870s, Josias Willard Gibbs, American scientist, introduced another one thermodynamic function, that is Gibbs free energy. What is called Gibbs free energy? Available energy to do work in a system, that is Gibbs free energy. Gibbs free energy is defined as G equal to H minus Ts, where G is Gibbs free energy, H is enthalpy, that is heat content of a system, T temperature in Kelvin, S entropy. Entropy means randomness or disorderness of a molecule of system. Gibbs free energy, G is extensive property, state function, single value function. These are characteristics of Gibbs free energy. What is called extensive property and intensive property? Extensive properties are depend upon amount of matter, but intensive property does not depend upon amount of matter. Extensive property example volume, mass, energy, etc. Intensive property example boiling point, melting point, density, etc. What is called state function and path function? State function, property of system depends only state of system, but path function depends on path by which the system achieved a particular state. What is called single valued and multi-valued function? Single valued function have a single value for particular entity. For example, consider two set x, set y. Set x consists number 1, 2 and 3. Set y consists a, b, c and d. One is value of set x is the value of a in set y. Same, the value of 2 in set x is the value of d in set y. But value of 3 in set x is value of b and c in set y. So 1 to a and 2 to d single value function, but 3 to b and c is multi-value function. Here Gibbs free energy G is an extensive property, single value state function. Let us consider a system involved in a reaction. At that time, state change from 1 to 2 at a constant temperature. At state 1, Gibbs free energy G1, enthalpy H1, entropy S1, and state 2, Gibbs free energy G2, enthalpy H2 and entropy S2. Now we calculate change in value at end of the reaction. So change in value is final value minus initial value. Therefore G2 minus G1 is equal to H2 minus H1 minus T into S2 minus S1. Now we write instead of G2 minus G1 del G and H2 minus H1 del H, S2 minus S1 del S. Therefore, at a constant temperature, change in Gibbs free energy del G equal to change in enthalpy del H minus T into change in entropy del S. Already we know del S total is equal to del S system plus del S surrounding. For reversible process, del S total equal to 0. Because for reversible process, del S system is equal to minus del S surrounding. Now substitute del S system as minus del S surrounding in del S total value. Therefore, del S total is equal to minus del S surrounding plus del S surrounding. Plus del S surrounding is cancelled by minus del S surrounding. Therefore, del S total is equal to 0 for reversible process. Reversible process is called equilibrium process because equilibrium means same. In reversible process, both forward and backward reaction proceed at the same rate. So, reversible process or equilibrium process. This process del G value is 0. For spontaneous process, del G total value always greater than 0 because spontaneous means increase in entropy. So, del G total value greater than 0. Del G total means sum of del G surrounding plus del G system. Therefore, del S system plus del S surrounding greater than 0. What is del S? From entropy definition, del S is equal to dq by T. Therefore, del S system plus dq surrounding by T greater than 0. Now we substitute instead of dq minus del H because in exothermic reaction heat is released. So final heat energy is always lesser than initial heat energy. Therefore, change in enthalpy del H always negative value. So, del S system minus del H system by T greater than 0. Now, we take LCM for 1 and T. LCM is T. Therefore, T del S system minus del H system greater than 0. Denominator T go to right side. Right side 0. So 0 into any number 0. Therefore, T del S system minus del H system greater than 0 for spontaneous process. Now we take negative sign outside. So minus del H system minus T del S system greater than 0. Now we write del G for instead of del H system minus T del S system. Therefore, minus del G greater than 0. That means negative value. So for spontaneous process, del G value less than 0. Del G means what? Del H minus T del S. Therefore, del H minus T del S less than 0 for spontaneous process. Del H system means enthalpy change of a reaction. T del S system means not available energy to do work. Therefore, enthalpy change minus not available energy to do work is equal to available energy to do work of a system. Therefore, Gibbs free energy is a measure of available energy to do work of a system. So, for spontaneous process, del G value is always less than 0. Non-spontaneous reaction is opposite to spontaneous reaction. Therefore, for non-spontaneous reaction, del G value greater than 0. So, from above concept, what will we understand? Del G value is equal to 0 for equilibrium process. Del G value less than 0 for spontaneous process. Del G value greater than 0 for non-spontaneous process. Remaining Gibbs free energy concept we will continue next video class. Thank you students.